Hello, my name is Nilady and today I will be presenting Emath 3 assignment.
I'll start by explaining what the Euler method is. We are given an equation and instead of solving it directly with calculation, Euler method lets us estimate the shape of the curve by estimate the next value of y step by step. In my graph, the curve represents the real solution. So what Euler does is, we take a small step forward from xn to xn plus 1 using a fixed step side h along the tangent line to the solution curve. So this means h equal to xn plus 1 minus xn. Then I use definition of the derivative dy by dx equal to yn plus 1 minus yn divided by xn plus 1 minus xn. And substitute in h equal to xn plus 1 minus xn dy by dx equal to yn plus 1 minus yn divided by h. Rearranging this gives us yn plus 1 equal to yn plus h times dy by dx. And since dy by dx equal to f of xn comma yn, we can substitute into formula and it becomes yn plus 1 equal to yn plus h times f of xn comma yn. This formula allows us to step forward from point to point, estimating the curve using straight lines. Next, I will use Excel to show Euler methods. I have created 4 key columns, xn, yn, dy by dx, and yn plus 1. The x values increases by a fixed step size of 0 by 1. The yn column holds the current y value at each step. It gives updated after every calculation. For the derivative dy by dx, I use the formula xn squared plus 1 divided by yn. Then to find the next y value, I use Euler formula yn plus 1 equal to yn plus h times dy by dx. To estimate the final y value when x equal 1, I calculate each step from x equal to 0 to x equal to 1 using a step size of 0 by 1. There's 10 steps in total. At each step, I substitute the correct x and y values into the Euler formula yn plus 1 equal to yn plus h times f of xn comma yn, where I replace f of x comma y with dy by dx. After completing all 10 steps, I found the final approximation value of y at x equal to 1, which is about 1.91137. Then I also use the general solution to find the exact value of y at x equal to 1. Starting with the differential equation dy by dx equal to a squared plus 1 divided by y, I solve it by integrating both sides. This gave me the equation y equal to square root 2 into q over 3 2x plus c. To find the constant c, I substitute the initial condition y equal 1 when x equals 0. Solving that, I found that c equals 1. Then, I substitute x equal to 1 and c equal to 1 into the equation to calculate y. The result I got was approximately 1.91485. I then calculate the approximation error by comparing Euler methods to the exact solution. The formula I used was error equal to the exact y value minus the approximate y value. Using Excel, I subtracted the Euler estimate from the value obtained using the general solution. This gave me an error of about 0.00347. This small difference shows that Euler method provided a fairly accurate result.
That's all and thank you for listening.